Hello and welcome to the podcast According to Sci-Faith, where we discuss topics revolving around the compatibility of science and faith. I'm Joshua Göcking and you're listening to According to Sci-Faith. Episode 37, Physical Units. Already in school we learned to use units, be it in mathematics or in physics or in other disciplines. I can remember from my time in school, even in primary school, when every time we had some calculation, for example in maths, and we presented the results to our teacher verbally, then usually when we said just a number like 37 or something, then he would respond with 37 what? 37 buttons or whatever. And so this was also always something that we got aware of, that we need to use proper units when talking about problems or things, and even when in the problems the units were not clearly given, then we needed to basically say the units in this kind of quantity that we were computing, so like money units. So this was how we used it. So you learn from an early age on in mathematics, in physics especially, that units are really important, and they are indeed important. But what comes with it is oftentimes, I think, is a wrong interpretation of units, or sometimes one does not really realize what units really mean, or is not able to put them in the proper context, because as important as units are, they are also kind of arbitrary, and there is some freedom in how you choose your units, and this we want to discuss in today's episode. So if you might have noticed by now that there are many different kind of units. So there are unit systems. So for example, just in your everyday life, if you travel internationally, you might have come aboard that there are countries who use, for example, the metric unit system, and there are other countries that use the imperial system. And this is basically, the differences are quite big in some cases. So in a metric system you basically have meters and kilogram and so on, these kinds of units, which are oftentimes, or not oftentimes, basically all the time, they are structured such that they are in a decimal way, or in a way where the next unit, the next higher unit system comes in steps of 10 or even 100 or even 1,000. So if you look at meters, the next higher order would be kilometers, which is 1,000 meters. So it's always in this way. If you look on the other hand into the imperial system, there this is not always the case. So for in the case of length, you will have inch and 12-inch amount to 1 foot. So there you have a difference. There it's 12 inches that are 1 foot, and not in a metric system where it would be 10 or 100 centimeters which would amount up to 1 meter. So there is this difference in this scaling, and still you can see that both units achieve the same results. The societies who use these units work pretty reasonable, so there are no issues in using one unit system against the other. You might at least assume from seeing it from the outside. So the question that comes about is, of course, okay, who is using the right units? What are the proper units that are to be used? And this question cannot really be answered, because as it comes out, units are kind of arbitrary. So as we see, you can use both of them and achieve the same results or similar results if you don't miscalculate at some place or do any mistakes there. And therefore those units are kind of arbitrary, and which units are the right ones cannot really be answered, but units can be more practical for certain purposes, or less practical for certain purposes, depending on the situation that you are looking in. and that the units that you use have to be independent of what you are of the physics or what is behind of the nature behind it. You can clearly see from an example I will show you right now. It's for example, just think of an alien society. So if you believe that there are aliens, which I do not, but let's assume there are some aliens on some distant solar system, some distant planet, and they develop science. They also handle or work with each other and so on, and so they need some units to exchange their goods and so on. And in this endeavor, they develop some units, and in general, these units will be completely different from the units we have in our society. So if we travel there and we meet up with them and we try to exchange goods because maybe they have some goods we would like and we would not have on Earth, and the other way around, then of course we need to find define a measure how we can we exchange them. And most likely they won't know anything about meters, about feet, about any other scale unit we have here, and therefore we need to find a way to get around it. So but what they are describing with there, so if they say we give you this quantity and that much of it, it is describing a real natural materialistic quantity that they really do have. So really physical, they describing something that is real, that is really there, although they use different units. So from there you can see physics needs to be independent of the units you use. So you always need to be able to describe the physics or the nature or what you are describing in science. You need to always be able to describe it in a way which is independent of the unit system that you are using. Of course, it will be always in some sense dependent on it, since you need to use units and you cannot just throw them out, but you need to be able to understand that the science that you describe at a base level is not depending on these units, and that you always can change into a different unit system, and it wouldn't change the science, it wouldn't change the physics behind it. It just would change the values in a way that they comply with the units that you are using. So having seen this, it might be reasonable to ask, okay, what are practical units to be used? And as I said before, this really depends on the situation that you are in. This really depends on the context that you are in. For example, for the everyday life, it turns out, or at least that's my opinion, that the imperial system is a lot more advantageous than the metric system, because as I mentioned before, you have this difference in, for example, in length of feet and meters, that if you have meters, you have it always to the next higher order is always at 100 of something or 10 of something, always in this decimal or potences of tenths, where this the next order appears. And this is different in the imperial system, where you have, for example, have 12 inches amounting to 1 feet. And the advantage in everyday life that this gives you is that if you need, for example, a third of something, if you have meters, that's pretty tricky, because a third of a meter would be 33.33 and so on centimeters. So it's really difficult to calculate with these quantities. Not really difficult, but it's more difficult than, for example, if you have feet and you need a third of a feet, then that's just 4 inches. So that's a lot easier, and therefore it's really advantageous in these everyday life situations. And that's me saying it as somebody who is accustomed to the metric system and who also uses the metric system, because I'm just used to it. This is also the other problem that you need to consider, that even if some units are more practical than others, especially in this everyday life, you can just not switch from one unit system to the other, because you are so accustomed to one that it's really difficult to switch from one to the other. And even years into living in a system where you use the different one, I heard that usually you still make this computation in your head and you turn it around. For example, if you if you live in Europe, for example, here in Germany, so in 2002, there was a currency change, and we went from the D-Mark, the Deutsche Mark, we went to the new currency, the Euro. And still these days, less and less, but still today, there are some people who, when they are encounter Euro as a currency and a quantity of euros, they still compute it back to the D-Mark. So this shows how deep these units can be in one's mind, and therefore it's not just not as easy to say, okay, we just will use this new unit system because we think it's more practical, because it's really being accustomed to a system. And even if this would be less advantageous in some circumstances, the barrier of of getting accustomed to a new one is usually much higher, especially in a case of units that you use in your everyday life. So having said this, this argument that the imperial system might be more advantageous in everyday life, if you go into physics, it's completely the opposite. There usually the metric system is much more advantageous, which is the reason why it is, for the most part, in most disciplines, or most part of physics basically, that deals with also the physics that we see with our eyes, so mechanics, electromagnetism, and so in these areas there's usually the metric system used, which is be more specific. It's the SI system, so the SI units, and they are not only so. Here we not only have just a unit system, but also it's kind of a basis of units. So in one podcast, no, not in a podcast episode, but in one article on my blog sci-faith.substack.com, I talk about basis in the sense of linear algebra. And if you have not read it, it's easy to understand what I mean by it. A basis is basically something like if you think of colors. So we have basically infinitely many different colors, but there are three colors from which you can combine in a way that you can achieve to get all the other colors. So this would be blue, green, and red. If you mix them with a certain amount of each color, then you can basically, if you do it correctly, get every color of the color spectrum. And this is basically a basis. So they are a basis of the color spectrum. And in a similar way, in linear algebra, you have this, that you can have bases of these vectors that you can combine to span the whole vector space, which has infinitely many vectors, but can be spanned by just as much vectors as dimensions this vector space has. So think of the colors if you did not understand, have not understand what I said before. And this is basically a basis. And for a unit system, you have it as in a similar way. There are some quantities with which you can basically, or some units with which you can combine together to achieve basically all the other units that are there in this world. If you just think about, we have time and length. So in the metric system, this would be meters and seconds. And this we can combine to meter per second, which would be a velocity. So the velocity is not a unit in itself, but is a unit that is combined of two other units. And this is the case for many units. And you actually, to describe all of physics, you actually just need very few units, and those are given by this SI unit system. And I just want to briefly mention those. So as I said, for time we have seconds, for length we have meters, for mass we have the kilogram, for the electric current we have ampere, for temperature we have Kelvin, then we have the mole, and for the strength of light we have candela. So the last unit is basically when I was studying physics, it was mentioned once and never occurred again. I think if you specialize in something like astronomy and so on, then it might occur more often. But it is an important unit, but in many other cases you are completely oblivious to this. The mole is also more a part of chemistry, so you rarely it occurs in maybe in some thermodynamic problems, but it's also pretty rarely. But the other units are really pretty current occurring, and you need them pretty often. Time for a short break. And as always in these breaks, I just read some portion of my new book or my new novel, Alien Thoughts, where it is just about thought control, mind control, and so on. So let me just read some extract of it. Since she was still agitated after the day's experiences, she decided to calm herself down with some entertainment. She started the entertainment program on her neurochip and closed her eyes. She selected a stand-up comedy program. The neurochip projected a live stand-up program onto her inner eye by tapping into her imagination. The program featured her favorite comedian Frank Thomas. He was one of the few privileged people who were allowed to perform their comedy live. To get this permission, each joke had to meet the requirements of the government. Since the AI's examination of the jokes could take several seconds depending on the type of joke, only those comedians could be considered for which this time was sufficiently short. This ensured that no unauthorized jokes made it into the live program. However, it was not only a matter of ensuring that no unauthorized jokes were made, but rather to use humor specifically to promote the ideals and goals of the government. Boris had understood early on the importance of humor and entertainment for mind control. Humor could be used to skillfully make people's worldview appear absurd, make them turn away from it, and make them accept the worldview that was presented. Comedians who understood to use this as the goal of their comedy quickly became successful. Even when they made fun of things in the government, they did so with the undertone that is nevertheless good and right. Studies showed that without the use of humor, it would have taken much longer to make the neurochip requirement and the control by alien thoughts socially acceptable. Frank Thomas was a master at using humor to promote the ideals of the government without letting the laughter fall by the wayside. For example, he just told about how he discussed with the neurochip whether it was okay to eat another candy bar after the hamburger. He reenacted the discussion in a sketch-like manner. Patricia couldn't stop laughing and gradually fell asleep while she was still watching. So in this short excerpt, it's about this comedian Frank Thomas, who will also play a crucial role in the later part of the story. So if you found this interesting and want to find more about this, then I really encourage you to get the book. You can get it at Amazon. Alien Thoughts, it's called. Just type it in and maybe also my name, then you will clearly find it. And if you have read it and you liked it, then I really would be glad if you could leave a review. This just helps other people to understand what a book is about and see if this is also something that they might like to read. What's important here also to note is that those are defined in some way. So let's say example, the meter, in the beginning it was just like that you had just some length which you defined to be a meter. There was some reasoning behind it, but that's basically pretty much it. And everyone had kind of a stick which was 1 meter long, and then you said, okay, this is a meter. And the problem with this is that as you might know, a stick, if it is made from wood, for example, from time to time it might break, something might get off, and so it is not really that accurate anymore after a certain time. And even especially if you need to really do precise measurements, this is crucial. You can just not allow for something like that to happen. And in the case of physics, you really need this precision, and therefore you need a way to define these quantities, to define these units in a way that are not dependent on materials. And this has been done to the most part. So for time, for meters, for example, to stay in this example, you defined it over the distance the speed of light travels in a certain time. So this is a natural quantity. It's in nature. This does not change. It cannot be kind of destroyed in some way, like a stick, which says what a meter is can, and therefore it is you can have this as a really firm quantity, and even you can transfer it easily. So with this, before you had to have this stick, you had to buy it somewhere, and somebody need to be certified to give you these sticks who were really 1 meter. He could not cheat you out of it. He needed to have this be a certified builder of these, and in this way you can even go to some alien society and say them, okay, just measure this time and then measure how far the light travels, and then you know what a meter is, and they will be able to figure that out without you having to hand them something over. And for the same thing is for time. Time is defined by basically atomic frequency, I think, for cesium, and there it's some frequency that it has. With this you define the second. And also for pretty wild, at least until 2029, pretty wild was the definition of the electric current, of the ampere. And this has basically been up to 2019. The definition basically was that you have two wires that are 1 meter, infinitely long, that are 1 meter apart, and current are flowing in the opposite directions through those wires. And 1 ampere is the strength of current that is flowing when these two wires attract each other with 10 to the minus 7 Newton. So this is the unit of force. So this was the definition up to then. They changed it. But the funny thing is, so usually oftentimes this was a question that professors asked people defending their PhD thesis just to get them out of the concept, because usually you forget this definition immediately. But of course, as somebody who's wanting to get a PhD, no matter what area, you have to know this because it's basic knowledge. But for now, in 2019, they changed it and they defined it on the elementary charge of, for example, the electron, which is a natural constant, and therefore it's defined in nature, and therefore it's also firm defined. So good news for people defending their PhD thesis. The other quantities like temperature and so on could also all be defined on some natural quantity. One quantity where this has not been could not be done yet was for the kilogram. So for the kilogram, the quantity that measures this is still the basic kilogram, which is used as a measure, and this is highly preserved somewhere and taken into account that it is in a good shape. But even though it still loses due to naturalistic effects, it uses micrograms of its mass every year, and so it's not something that is reliable for a long time, and you have to always renew it, and so on and so on. And there is an endeavor in really trying to get this independently defined as the other units are. There is some experiment where they try this is to create out of silicon, I think. They try to create a sphere, a perfect, almost perfect sphere, and define the kilogram on this one in a way where they use other units to define it and so on. So this is an area of research where they still try to get these units completely independent, established in natural constants. Yeah. So, but this SI system is basically used in science. However, not all of science. So you have different areas of science where where different units are used. For example, if you go to astrophysics, you usually do not use meters. Maybe in some cases to show you how big things really are, as in popular science books where they tell you how many 1,000 kilometers the solar system is. But usually you use units that are easier to track, where you don't have these high terms. And for example, in astronomy, it's mostly parsec that's being used. Maybe in some cases also light years, but mostly those units are used there. And if you go to the physics of the small areas like particle physics, there are also different units are used. There you use, for example, usually GeV or giga electron volt, which is basically the only unit you use there. And the reason for this is, let's also just look how the theoretical physicists do it. Usually they don't really care about units, because as I said, units are kind of arbitrary and you can arbitrarily choose the unit system. So physicists in theory just say, theoretical physicists just say, okay, since the units are arbitrary, then I chose them as easy as it can be. And so they usually choose the usage such that h bar, which is Planck's constant, and the speed of light are set to 1. And then you don't even need to take care of these constants. You don't even need to write them out, because they are 1 anyway. So it's just a factor of 1, which you do not need to write down. So in this case, for example, Einstein's relation E equals mc square becomes just E equals m. So and this makes it more explicitly clear what you're actually saying with this relation, because this relation does not state something about energy and the speed of light, but actually it states something about energy or matter being some form of energy. And if you go further and consider that this is only Einstein's relation for bodies who are at rest, then and consider it for bodies who are moving, then you have E equals the square root of m square, so the mass square, and plus p square, so the momentum square, so the amount of which it is moving squared. And this makes it more explicit what really this energy relation states, namely that the energy of any given particle or object is given by its mass and its momentum. That's basically what it states. And this factor of light speed that occur there are just for proportionally, just to make in the unit system of SI unit, make everything look right, or get to the right results, to the right units in this unit system. So therefore, in particle physics, you take a similar advantage. You change the units such that you have everything given in units of energy. So basically, you can transform every unit into one unit, let's say the one of energy, and then compute it all in these units. And this you have in particle physics. There you have the masses given in giga electron volt, you have the energy given in giga electron volt, the momentum, the time, and so on. So the time actually would be 1 over giga electron volt, so it would be the inverse of it. But you have everything basically given in one quantity, which make the equations much more easier, or the results much more easier, and you just need to talk about this in this quantity. if you would be completely consistent, you would actually say, okay, mass is actually the giga electron volt divided by c square, but you do the trick basically like the theoretical physicists and basically say, okay, we set c to 1, and then you get also rid of this. So this is a much easier way to talk about it. It's much easier to calculate in these units, and only once you really have to get everything out in these SI units, then you have to do a little bit of calculating, but this usually never happens because you usually stick to measuring everything in this GeV area, and all the particles, the masses of these particles are usually formulated in GeV and not in kilograms or some other unit. So what we can learn from this is that units are indeed important, so you cannot just say something is of some value without stating which unit you are talking about, because otherwise it's not clear what you are really talking about. But the specific kind of unit you use is really arbitrary, so you have a freedom of choice in there, and you have also a freedom of choice in many other states of where it's just about notation, where it's just about convention. For example, there's also in the special theory of relativity, or not only the special but also the general theory of relativity, there you have this Minkowski metric. So this is basically we had special theory of relativity, we had three-dimensional space, and now since we recognize that time is an own dimension, we need to account for that, and this we do by using the Minkowski space and the Minkowski metric. And in this Minkowski metric you have the additional dimension of time, but with an opposite sign. So you can either have the time with a minus sign and all the others with a plus sign, or you can have the time with a plus sign and all the others with a minus sign. And which one you use is basically arbitrary. And there are kind of discussions among physicists about which units are the correct, which metric is the correct one to use, and there are really some kind of not really serious, but some kind of fights about which one is the right one, which one is the wrong one. And therefore there you can see this is also the case there, similar with the units, where some people are also fighting which units are the correct one, is the imperial or the metric one the better one. And here you have the fight basically with this metric. So you have this in many areas where it is just about notation, about how you describe the physics behind it, but the physics or the science behind it will always be the same. It will not be depending on units. So it is actually important to use units and to be aware of what units are and to understand how units work. But if you understand and if you see it, then you see it's not important what kind of units you use. It's more important that you know how to use them, that you know what they mean, and that you are consistent in your use of your units, because otherwise you will make mistakes. And I think this is the important part to understand, that although they are important, there is a freedom of of which units you use, and you only need to be consistent in that and be clear about what you are doing in that, and then you have this freedom in your choice of units. And I think in the spirit this can be also interpreted in a way that as the Bible tells us, there is freedom in the spirit, so there is a freedom in how you live out your life in faith, and how, of course, there is the clear word of God which gives us clear instructions, and those are not to be changed or something like that. That's not what I'm talking about, but there are different callings, there are different ways you can live this out, and you can live in that. And I think there is this freedom of where you live in that, and where you can be guided by the Holy Spirit how to live in that. And I think many of times we just get, or some Christians just get stuck in this using of different units, so to speak, and try to think this is the right one, or if this is the right one. But in some sense, it's some kind of, it is really arbitrary, and there is a freedom in it that we need to accept. And with this, I don't mean that some doctrines are wrong or something. I just want to state that there is a freedom in the spirit, and we need to embrace that, and we need to be able to live in that. And this, I think, we can compare to this difference in, or to the really importance of units, to have units, to compute in units in physics, but also to this freedom in which units you want to choose. But in the end, it will be the same. In the end, we will describe the same physics with those units if we apply them consistently, and also in the spirit. In the end, we will serve the same God if we apply our point of view, or from where we are approaching it consistently. So that's everything for today's episode. I hope you liked it and you enjoyed each part of it. If you want to get in touch with me or discuss a topic or want to give me some feedback, then feel free to contact me using the contact form on my website, sci-faith.de/en. And there you can go to the contact tab and contact me. And if you have any other things or episodes you want to have covered there, or topics you want to have covered, feel free to contact me there. Also, if you are not yet familiar with the format in which this podcast is produced, let me just briefly explain it to you. So there is always at the beginning of a month or of a block, there is a big block of 4 episodes in one thing. It's kind of like a preview, which I call it, where you have the next 4 episodes all in one episode together, combined. And this is for people who like to hear long format podcasts, who have a long way to work or something else, where they can listen to a long episode and can then have a preview of the next 4 episodes all at once, and are completely up to date from the beginning of the block. For those who like their episodes shorter, who prefer it if they have a half an hour or even less of a podcast episode, for those, there is every week afterwards will appear a podcast episode almost in that length, and this way I can publish every week a new podcast every episode, and everyone can have it his own way, either once a month a long chunk of content, or once a week a shorter format podcast episode. So I think that's the best way for everyone, and also for me when I'm producing it. Please also note that this is an independent podcast, which means that it is recorded, produced, and marketed by me. So I really need your support in this. So if you like this podcast, then give it a 5-star rating. And if you have the time, even write a review to it. This just helps other listeners to become aware of this podcast, and then people who might be interested in this content can become aware of it. Also, if you have friends who you think would like this content, then recommend it to them and share it with them. Also, you can support me in other ways, for example by reading my blog and subscribing to my newsletter, or even by reading my books, which you can find on Amazon. For example, there is my latest novel out now is Alien Thoughts, which is pretty entertaining from the feedback that I gotten, and so it's also in some way related to science and faith. The topic of it is also in there, but of course you can also read the book to this podcast, Sci-Faith, The Compatibility of Science and Faith, which is also available in English since last year. Thank you for that. And now I wish you a wonderful day, and I'm looking forward for you to tune in again next time.